Your homework from Friday was to draw that vector diagram representing the vector walk that you did on Friday around the school, plotting that vector diagram, and then resolving the vectors. In other words, adding the vectors together to get the total of the vectors. I've got an example of one up on the board right now that you might have taken. Okay, I walk 20 meters one direction forward, then I turn at 30 degrees and walk 10 meters, and then I turn and walk 15 meters across, and then I walk 5 meters back at an angle of 60 degrees. We want to find the sum of all these vectors. So first thing before we do anything else, we look at this and say, at least in our minds, 5 words. What are those 5 words? I don't like funny angles. So we got to get rid of funny angles. In fact, there's 2 of them that we got to get rid of here. Let's get rid of the 30 degrees first. This is x, this is y, and this is 10 meters. We're going to say cosine 30 degrees is equal to adjacent over hypotenuse, x over 10. So x will be equal to 8.66 meters. We're going to say sine 30 degrees is equal to opposite over hypotenuse, or the y component over the hypotenuse. Y ends up being equal to 5.0 meters in that case. So if we want to, we don't have to, but if we want to, we can physically erase that vector and replace it with 8.66 this way and 5.0 meters this way. It looks simpler now. It looks a little bit easier to handle now because we've only got 1 funny angle instead of 2. Let's go back to the other funny angle, the 60 degrees. Let's redraw that one. 60 degrees right here. This is x, this is y, and this is 5.0 meters. Let's say sine 60 degrees is equal to opposite over hypotenuse, which in this case is x. So last time it was cos for x, this time it's sine for x, because it's the opposite side we're looking for. Sine 60 is 0.866. X is equal to 4.33 meters. The y component, we're going to use the cosine function. It's equal to y over 5.0. Y ends up being equal to 2.5 meters. So if I want to, I can replace this with 4.33 meters to the right, 2.5 meters down, and 4.33 meters to the right. Make sense? Now the question's pretty easy, right? I've done the hard part. Now the question's pretty easy. So let's do this now. Let's pick a new color. Only for you guys, because I like you guys so much. Let's go with, you want purple? So let's do our x's and our y's now. First one, how much of it's x? How much of that first one is x? None. How much of it's y? 20. How much of this one's x? It's an 8. 8.66 is x, 0 is y, 0 is x, 5 is y, negative 15 is x, careful with the negative there, 0 is y, 0 is x, negative 2.5 is y, and 4.33 is x, and 0 is y. Let's add them up. 13, negative 2, I think it works out to be. This is going to give me 25, 22.5. Now we're going to combine these. Is that right? So let's combine these now. We've got a negative 2 to the left. We've got a 22.5 upwards. And we're going to find the final resultant vector, the sum of all those vectors, ladies, the sum of all those vectors by doing the Pythagorean theorem. And the angle, focus on this one today because that's what we learned new on Friday. The angle at which this vector is, the sum of these vectors, the resultant vector, drawn at the start of my vector diagram, I'm going to find it by saying the inverse tan function of opposite over adjacent. So in this case, it would be 22.5 over 2, which is going to give me an angle that's pretty big. Okay, I'm going to guess 80 degrees. Somebody try that. So our angle there would be 84 degrees. Make sense? Good. All right, one quick little thing here. We've now learned to calculate the sum of the vectors, at least the magnitude of the sum of the vectors. Ultimately, we want to get a right-angled triangle, do the Pythagorean theorem. Not so bad. We've now learned to calculate the angle, so we get a direction of the vector, which is important because the sum of a vector is a vector. But we're still not quite complete there. We're almost complete, but not quite. If I said that this one was whatever the hypotenuse was, whatever r is, at 84 degrees, what do we mean by that 84 degrees? If you don't see that diagram in front of you, what does the 84 degrees mean? 84 degrees relative to what? It's always got to be relative to something, right? Always relative to something. Well, what are we going to make this relative to? Let's say we got a vector like this, and its angle is 30 degrees. We're not going to try to find the components for a second. We're just going to express what that 30 degrees is relative to. When you see a picture, okay, we've got the frame of reference already drawn, but when you're saying it in words, how do you express it? This would be 30 degrees north of east. This one would be 25 degrees west of south. So how do we figure that out? Well, here's the thing. You can look at this vector and say, there's two directions this is going. You know this is going north, and you know this is going east, right? It's going up, and it's going to the right. It's not going west, because west is to the left. It's not going down. It's not going south, because south is down. This one we know is going south, down, and we know it's going west, to the left. So we know it's going west and south. Now, the question is, do we record this as 30 degrees north of east or 30 degrees east of north? 25 degrees west of south or 25 degrees south of west? Take a look at where the angle is measured from. This angle can be measured from either the x-axis or the y-axis. In other words, it can be measured either from the east or from the north. Where is it measured from in this case? What axis is it touching? Yep. It's the x-axis, the east axis. So it's going to be north of east or north from the east. In the second case, we look over here. Okay, where is it measured from? Well, we could have an angle right here measured from the x-axis, but we don't. We have an angle instead right here that's measured from the y-axis, the south axis. So we're going to say not south of west. It's not south from west. It's measured west from south or west of south. Does that make sense? Let's try another one of those. What's that one going to be? Give me the two directions first, okay? North, south, east, west. Give me the two directions that we have here. I don't care what order they're in right now. What do we got? Yep. We got north and west. So is it north of west, or is it 20 degrees west of north? Well, we got two axes. We got a north axis and a west axis. Where's the angle measured from? There's the north. This is the west. Is that angle measured from the north or the west? Which one's it touching, the north or the west? Joseph? The north. So what are we going to say? 20 degrees north of west or 20 degrees west of north? West of north. West from north. The angle is measured from the north. Okay. Let's try another one. "30 degrees. What are my two directions here? North, south, east, west. What are my two directions? Okay. Well, forget about the north of east or east of north, whatever. Just give me the two directions right now, north and east. So is it 30 degrees north of east, or is it 30 degrees east of north? Well, let's look at where my angle is measured from. I got two axes here, my north axis and my east axis. Which one's it touching, north or east? Right? So it's measured from the east then. So it's north of east as opposed to east of north. Oh, have a look at this one. That's 30, by the way. That's got to be 60, right? How would we express that? 60 degrees. Which axis is that touching? Jared, which axis is that touching, the north or the east axis? Good. So we'd express that as 30 degrees. Good. East measured from the north or east of north. So now we can express not only the magnitude, we can express not only the direction, but we can express the direction relative to something. Just like when we first introduced displacement, we talked about we always had to have a frame of reference, right? 5 meters north of the front of the room. Okay, 3 meters west of the door. Okay, it always had to have a frame of reference. So we have to have a magnitude, we have to have a direction, which is the angle, and we have to have a frame of reference, which is the north of east or the east of north or whatever the case may be. Got it? One more quick example. You guys are going to do this one. I'm going to have you add two vectors together. Let's say 10 meters here, and let's make this one 10 meters as well. But let's make the angle here 30 degrees this way. Now, this is easy compared to some of the questions you've done to this point. The point of this for me is not so much can you add the numbers together, can you reconcile them, can you do the Pythagorean theorem. The point of this one is more, once you do get your answer, can you give me the proper frame of reference? So I want you to add these vectors together and give me an answer for the sum of the vectors, including the magnitude, the angle, and the frame of reference that we're in here. We'll take a look at it a second in the group, as a group here. Time to look at this question now. We got a funny angle here. We don't like funny angles, so we get rid of it. Let's draw it off to the side here. We got 10 meters. We got 30 degrees right here. We label our x-axis with x and our y-axis with y. Let's find the x component here. It's the opposite side of the triangle, so we'll say sine 30 degrees is equal to opposite over hypotenuse. X ends up being equal to 5.0 meters. The y component is the adjacent side, so we'll say cosine 30 degrees is equal to adjacent over hypotenuse. The y component ends up being equal to 8.66. If I want to, I can redraw this so that I've got 8.66 downwards and 5 over this way. Let's add these up now. X's and Y's. We got 10 and we got 0. We have 0 and we have negative 8.66. We have negative 5 and we have 0. We add these up, we get 5 and we get negative 8.66. Let's combine them. 5 to the right, 8.66 down. The resultant vector is drawn from start to finish. That's what we want to find. The angle is drawn at the very beginning here. We're going to say r is the square root of 5 squared plus 8.66 squared. What do we get there? Should have a bunch of you have the answer already. Okay. Thank you, Joseph. 10 meters. And the angle would be the inverse tan function of opposite over adjacent. And I'm going to guess that's going to be somewhere in the range of 50 degrees. 55? 60 degrees? Thank you. How do we express that on the 60 degrees of what? West of south? Okay. Let's take a look at the two directions we're going here. If we go down and to the right, we're going south, not south and west, but south and east. Okay, now where am I measuring that angle from? I'm measuring the angle from, well, that dotted line, which is not an axis, and that solid line that's 5 meters, which is an axis. Which axis am I measuring from? The south axis or the east axis? The east axis. So it's going to be south of east, or is it going to be east of south? South of east, or south from east. Does that make sense? Good there? You guys feel okay about this vector addition stuff? So we don't have to write a quiz on it? Not today, but tomorrow. Okay, good. Good. Let's do that then. Let's have a quiz on this tomorrow.